Yeah. Good evening, my viewers. Again, I will welcome to this particular lecture or rather online tutorials-cum-lecture series on our YouTube platform mentioned here. In fact, we have launched our second, course, this online course on public water supply system, as I have written earlier also. Public water supply system, solutions to numerical problems and design examples or exercises. Okay, so meaning that in this particular course we will take up for discussion in details as much as possible within the time frame the different components required for a public water supply system, in particular the public water supply system which uses the surface water as source of water also, from which the water supply system, starting with the intake facility, it draws water, raw water from the surface water, this sources also. Okay, now here in my last lecture video, we have discussed that various points, right, relating to this public water supply system, and what we will cover in the course that we have more or less reasonably discussed in our last video. And particularly for the course, we have given an overview in the very first, or at the very outset, the very first video we have discussed this, we have outlined that. In the next videos we have also discussed that the intake facilities, because for any public water supply system using surface water source, that actually starts with this intake works also, as it is called, the technically or terminology what we use in this public water supply system, that is intake works. That means in this particular works, that the facility, we provide this all the necessary the units which enables, or which facilitates rather, to draw water from the river. This is the river intake we have shown earlier also. We have shown, I have added a few here the notation, or rather the captions also, right? So this we have added to this, right? Like suppose this one. Now this is a river intake, and that is a typical the plan, the layout of as I have written here, reservoir intake also. Regarding that different types of intake also, as I have already told you, that should consult with the manuals, CPHEEO manuals, and all this I have discussed in my last video. If anybody misses or so, then in that case, by one-to-one interaction or so, he or she could sort of gather the information regarding that, regarding books or references also. Now, these books actually, I have already shown that GARG, SK GARG, the water supply, this one here, the water supply and sanitary engineering, VD and BD, right? This is the PVN row, right? Then this is the manual on water supply and treatment. That is the Central Public Health and Environmental Engineering Organization, CPHEEO. This is published by CPHEEO. This is a routine publication every few years interval or so. This actually is it is updated also by the Ministry of Urban Development and this one, and it is uploaded in their website, so anybody can download this. It is free also. So that is why I will keep my that the basis of our discussions also, that is here. Now, as you know, in CPHEEO manual, I have already told, but I would like to repeat this here, that regarding intake, in fact, CPHEEO is not discussing much about the design also. So that is why we have taken the materials from other different other sources, like a American Water Works Association manual, that is AWWA manual. We have also taken some sort of some information and the data also from these books what I have shown, and also Davis book, that also we have consulted. Kasim's book I have already I have already discussed this and mentioned on the board what are the major books what we have we have been following for this course. Now in CPHEEO manual, water treatment part is well covered, the design part in the appendices, right? So we will discuss definitely, taking references from that only, but we will add from different other sources also. We will keep adding, or that will be on lecture wise we will add. And also the water distribution system, that also the network problem you will get, that I will discuss later. Then, but the conveyance system, while the CPHEEO manual has clearly discussed, very well discussed. It is well discussed in the CPHEEO manual. That is regarding the formula or equations also, and the basic theory and principles also of different the hydraulic considerations of the conveyance system also. Now here you see that the intake, as you see, coming back to this here, this is the plan, as you understand here. You need see that this is the plan. So a highway is going like that. This one we have, suppose we are seeing from the top, bird's eye view also of the system enter, so it will look like this, right? A very typical system. It is not necessarily always it will be like that. It will depend on your configurations, layout, what we require or what we choose, also select this one. But it is a typical system where you see that this is the reservoir, that is the dam. As you know that in a river also dam is placed, and this actually the storage. That actually the reservoir acts as a storage also. I think all of you have studied in your undergraduate level also in the water resources system also, water resources engineering. So reservoir, what is the function of reservoir, what is the function of barrage also. So this discussion I am not going to make here. Now here, with reference to or respect to that, the intake structure, this is suppose the intake structure, right? This is the plan, remember, and then it is connected to the the pumping station, and this here you see that here we have shown that one. Suppose this is this system here, this is over the bank also, right over the bank. and from here the water is collected through openings are there like that, right, and it is collected here from where it is actually pumped to the to the water treatment plant, because you see that it is surface water. So as it is surface water, it needs a rigorous treatment also, standard treatment, conventional treatment also. We will go for the conventional treatment, and when we will discuss about the treatment, water treatment, that time we will discuss about the treatment also. So the water, raw water, this is pumped directly to the water treatment plant, WTP. Okay, it may be quite far or very close or so, depending on the the topography of that particular area or so. So accordingly, the site of, as I have already told, that there are selection criteria for intake facilities to locate also. Similarly, for water treatment plant also, that is to be located very strategically, right? So because the first and foremost thing, remember that this is very important, in fact, for such planning and design. So here actually, as I have written over here, so this should be the platform from where it will be operated, the pumps and all this will be operated. This is a dwarf, or smaller size of that, but it is the descriptive, or this is a, you can say, elaborate, this one in little more details. Here it is smaller, so that we can show enter this one with reference to the water, the river, which actually serves as the surface water source also. So the platform, you understand, when it is over the bank, right over the bank also, then this platform must be above that HFL also, that is the highest flood level also, highest flood level. So when it is a question of river, then it is highest flood level also. Usually, you see that this is actually in different countries actually, different system is followed, and American system say they are actually 500 years flood they consider also, and accordingly they set the elevation of the platform on which the pumps, motors, valves, etc. intake, the pipelines also that we have, I think, written here. So these are placed here, right? So this actually, this is that one, but in our country, as I have already told in my last video, but I repeat it here, the highest flood level, the reference this year we consider as 1978, because there was a sort of floods all over the country more or less, right? So at least the northern part I know, eastern and northern India also. So 1978 flood is considered to be highest flood level also. Remember this. Number one point is this. And in why I have written this one, because in case of the reservoir also, in case of river, the highest flood level is coming, but in case of this storage of the reservoir also, this actually comes that the highest water level in the reservoir also, because the reservoir does not necessarily maintain the river water level also, right? Because the reservoir is a regulated kind of this one, where you can regulate the water level also, but the highest water level in the reservoir is considered the highest level over which at least 1 point, as I have shown here, you see that 1.5 meter above HWL, the highest water level also. Here also highest flood level at least, that 1.5 meter at least So that should be considered for constructing the platform also, from which the operation is done also. So operating, this is the operating platform. For that also, this is the river, this is the operating platform. This is for the detailed drawing. Here, this is this one here. Now here the control system actually is housed over that. This is okay, and while determining the area, surface area of that, as I have already told, that this actually should be sufficient to allow the installation and servicing of the pumps, number one. Number two, intake, these gates, screens, then overhead cranes or so, that actually, that must be, accommodated. So the space here, as you see, so that must be, this actually must be adequate enough to accommodate the pumps, motors, valves, then overhead crane if it is there, then the installation and servicing of the pumps if the pumps are placed over this. So there are two systems, as I have told, that either from here itself it is pumped, right, or it is connected to a sort of nearby pumping station, as I have shown here. You see that shown here, little away from this one, in a sort of location which would be suitable for locating this one. So that actually little away from that one, or right over this one. This is if it is right over this one, then in that case actually entire this that one is operated, all this pumping system, then all these things actually are operated from here, pumps, motors, overhead cranes, etc., valves, all are operated from here. But in this case it is operated from here also, remember. And then pumping assemblies are there, maybe multiple pumps, normally multiple pumps, minimum 2 or so, that should be placed this here in the pumping station also. So what I try or mean to say is that the pumping station for this case, where the entire intake is right over this one, and no pumping, other pumping stations or separate pumping station, then all these are placed here. Whereas if there is a separate pumping station also, suppose the pumping station is here and the river is there, so from there actually it is through an inlet or intake conduit or so, it comes to the this intake well also, from where it is pumped. Okay. Regarding pumping system, I am not coming or I am not going to discuss in details when we will discuss the pumping system also, because this is very vital for water supply and also for sewage treatment plant or wastewater treatment plant also. So that I am keeping for later this one, our discussion. Now this actually, this is the layout, and 60 years design period I have already discussed. I am not going to repeat this one. So this is the layout, right, a typical layout. And similarly, that the typical system is this. There may be other types of intakes also, not necessarily this kind of intake. So I have here tried to demonstrate this with an illustrative typical this diagram also, through which if we discuss, then you will understand that one, right. So this actually, you see that in different tiers this may be there, depending on your requirements also, right. So if you want to keep your operation or the drawal of this one or withdrawal, let's say, of raw water from the river also, and for the to meet of the design flow also in a flexible manner also, then you can see earlier I have discussed that on all the faces also, normally the that this is suppose the upstream, right, and the river is flowing to this direction, right, flow I have shown here, river it is flowing on this direction. Then the intake actually here, as you see, you understand from this actually. So this phase where the flow is occurring here, this direction, so this is normally avoided, because here because of the heavy or rather high velocity also, that I mean the this intake structure may be damaged also. Intake structure means the intake ports also, then cover and all these may be damaged, and also unwanted materials may enter into that, like fish. This actually is a troubling element actually in intake also. So that is why that actually the intake port has to be designed so that the fishes do not enter into this also. You understand why? Because this will decompose also. So that will contaminate the water. And also if it enters into the pumping system, it may clog the pumping system also. So that is why we have to keep for the intake design this fish species also, aquatic animals and including fish. So these actually should be kept out, right? Sometimes the electrically charged system to repel them also that is used, but in our country actually normally we adjust this by the size of this one, right? The fine screen, coarse screen, this way we keep them out also. Now next actually we will see the intake conduit. Next, this one, our component, that would be intake conduit. I think this is more or less clear to you. So I'm going to erase this one. So before that, I'm trying to sort of, more or less trying to explain how it works also. So for a reservoir like that, so this phase, what I was trying to tell, that this phase is normally avoided. That means this phase, okay. And preferred this phase is this downstream, because here the water velocity will be relatively lesser also. So this phase is first to be used or tapped also. This phase actually, that is the downstream phase, so water will come this way. This is the upstream also on the opposite side of that. So this actually, suppose this room is a sort of intake this well also. Now the windows are in different level, as you understand, right? So if you consider these windows are the inlet or intake, gate also, intake port also, right? So this actually intake this gate, so that is placed in horizontal level in different phases also, and normally in a staggered manner also, because in the same level structurally, in terms of structural stability also, if you consistency also, if you see that if you keep multiple this intake gates also in the same this horizontal level or in the vertical level also, then there is a possibility, it happens also, that there may be development of crack, because in that line actually this would be the very weak line also in terms of the structural stability also, and as a result of that this may develop crack. And as this the water intake well also essentially should be constructed with a watertight, in a watertight manner, and the design should be should follow the watertight or water retaining structure where no water leakage is allowed also, right? For this actually structural stability is important. Now intake conduit, this is intake conduit, if you see, That means when this is here, this is the intake conduit, right? Intake conduit. So I may write this one also here. So this is suppose intake. So water either may enter into that by gravity in the pumping station, from where it will be pumped to the water treatment plant also, or it may sort of by pumping action also, this will be sucked, this one, okay. So in both the cases, the water will be carried from this intake, this structure, from here to the pumping station also, as I have shown here, okay. Sometimes by gravity also, it directly goes to this one with a sort of, when this is suppose intake structure, if you consider this as an optional, there is this only a strainer, right? In the river, there is a pipe also. Of course, the pipe has to be supported or propped also against structural collapse also. So that pipe should not be broken also. So this pipe actually at the tip of the pipe also, there may be a mesh also. That means the screen also. That means the water being screened. The initial screening also, after that it is entering into the pumping station also. That also may happen. Here the intake structure is like that, and from where it is actually taken to the pumping station also, right? So depending on the velocity, because the velocity should not be very high, velocity through the intake opening also, because in that case actually the problems regarding the entry of unwanted floating bodies also, this may enter into that. So the velocity should be kept low, right? This actually I am coming to the intake gates little later. So before that, I like to cover this intake conduit also. So intake conduit, I repeat that this actually carries the raw water from surface water source also. From the intake, this will lead to the suction or the intake well also in a or near the low lift pumping station also. So either in that particular pumping station, when it will be working as pumping station also, that storage as well as pumping here, and here it would be storage is here, and it is taking that water to the pumping station also. So there actually low lift pump. It is actually low lift pump. I'm not going to the details of this. Low lift means that the capacity of the pumping or the system, the pumping this system actually should be designed or should be considered as a low lift, this one, not high lift also, right? Low lift, because the depth as I have mentioned 3 to 5 meters or so, like that. So it is considered to be low lift, this pumping also. Now for conduits up to about 30 centimeter in diameter, standard bell and spigot CI pipe. Bell and CI, so this one means this is like that. So this is a joining, because remember this is this side, another that. Okay. So this is also important to note that the bell and spigot, SPIGOT, this spigot, this CI pipe, cast iron means CI pipe. We have got cast iron, we have got RCC pipe, we have got, you know, that the steel pipe, we have got the PVC pipe, HDP pipe, different pipe material, ductile iron pipes, different pipe materials are used depending on your requirements also, and availability of course. So the bell is it is a bell shaped also. So this each pipe has got a, you know, fixed length also. In the market, what you see, that is normally 21 feet or so, depending on the availability in the market or so. Standard is say 21 feet or so. That is you know, that 6 meter, something like that, little above 6 meter or so. So this is actually you know, joint. This is, the pipes are jointed like that to make this length. In the pipe, you know, water supply system also, when conveyance or you know, that I think you must have seen that sometimes that in a particular area, suppose the water distribution or supply works are going on, where you will see that the cast iron pipe or steel pipes also are stacked alongside the road also. You might have seen this. So this is actually the pipes cannot be 1 meter, 1 kilometer long. It is sort of, particular this one, which are transported from the source of the pipes also. So this actually, how it is jointed, this is this way. So this is actually here. So one end will be bell shaped, and that actually, here also this is bell shaped, this is bell shaped, this is straight also. So here this should be plugged also, that by jointing materials also, like the lead cock also, and nowadays the O-ring also, that PVC, high strength PVC, this is actually just fitted into that. Okay, this is like that. Now suppose this is entering into it, this the gap also which will be there on all around the pipe. So that actually will be earlier the lead cock joints also, and nowadays O-ring that is there. There is a ring like pressure cooker, if you have seen pressure cooker, you must have seen. So there the O-ring. So similarly, depending on the diameter, O-rings are used, and this is actually slid to fix into the next part also. So that is how it is jointed also. Here also same, and it is given that length also by jointing so many this pipes, right, in pieces of pipe also, according to the requirements also. So this is a sort of intake conduit. When it is 30 centimeter up to that 30 centimeter diameter, so this kind of pipe is used. For larger conduits, steel or concrete pipes are used. So CI pipe, cast iron pipe, for up to 30 centimeter diameter, that is used, the pipe diameter. Always inner diameter we consider, right? Inner face, that means pipe. If you know that, if you see this one here, so this would be, if we draw the cross section of the pipe, this is just, so this actually inside this one. So I will discuss all details regarding that later, right? The very detailing we will make here in this particular course. So that way this course is worth taking, in the sense that is this will be dealt with with details, with illustrative diagrams or sketches wherever it is required. Then wherever this one, the full drawings, there we will consider the full drawings for discussion. and also the components will be, the drawings of the or diagrams of the components will be discussed in details also. So this actually, the CI pipe, as I have told already. The capacity of the conduit and the depth of the suction well shall be such that the intake prior to the pumping or pump, right? This is intake ports to the pump, intake ports, not pump, prior to. Intake ports to the pump will not draw air. So it will be, the depth and the capacity of the conduit, that should be, set or fixed, right, or designed also in such a manner that the intake port should not draw air instead of water or water with air also, because that actually may damage the system also, particularly the pumping system also. Now, a velocity of 0.6 to 0.9 meter per second in the intake conduit with a lower velocity through the ports actually gives satisfactory result. So 0.6 to 0.9, that means when this is actually intake conduit, so this is designed at a velocity 0.6 to 0.90 meter per second. So this you have to consider, right? And this will be flowing full because it is submerged. It will be flowing full, not partially full like this sewerage system also. And this actually, the Q which you draw divided by this velocity will give you the area, the cross-sectional area of the pipe, from which you can have air it is flowing full also. This is the area, the cross-sectional area, they say this, or AC, if we write AC, say cross-sectional area of the pipeline. That means this is the pipeline, suppose. I am showing once again this way, right? This is here it is drawn. So through that actually the velocity of this should be maintained, 0.6 to 0.9. So if you divide the Q design, I have discussed that Q design means the design discharge. Okay. In this context, let me tell you that the design flow, usually I have given a table also, right, where you will see that this actually, that is, you can say that the ultimate flow, that is 2 times or higher than Q, right? So Q which you get, normally Q, what you get, the design flow also. For ultimate flow, this has to be 2 times or so, accordingly you have to design. So that accordingly you have to design, because we have to keep a factor of safety also. Okay. So accordingly we have to design this one. And for pumps and motors, right? So for pumping system and this motors, these are required to be designed for 15 years or so, because the lifespan of these pumping machineries and pumping system also, this normally is considered to be 15 years or so. So that is why, while the mechanical parts including pumping system, that are to be designed that for 15 years or so, right? So this is Q or so. But this actually, for the civil structure also, like intake, this is a 60 years design life. So 60 years, at the end of that, it must meet that one. But by that time, say 4 times you might have to replace this one and the pumping system also. You have to replace, right? So accordingly, you have to design that. I think it is clear to all the viewers. If it is not, then we can discuss it, later in one-to-one interaction also. So this is that. Then this Q design divided by the velocity, the lower velocity better, because that is the conservative design giving the higher surface area, right? And then you find out that from area, this is equal to pi d square by 4. That is, the d is the inner diameter also, right? This is d. So pi d square by 4 will give you that area. From this actually you will get d. You can calculate d. So this is how it is, calculated in this particular case also, where the water is flowing full. Okay. So water, when it will be flowing full, that means when a pipeline will draw water under submerged condition. Suppose the water level is here above that, and it is by gravity it is going. So then, or if there is a pump or so, it must flow full. It cannot flow partially full, right? Again, when you see that the distribution, you are making distribution in the distribution at the end of this public water supply system, after treatment it is distributed or transmitted through transmission system, that is a pipe network system also. There also, wherever pumping is there, it must flow full, and wherever the pipe is under submerged condition also, that also flow full. But in case of sewage flow, this is not the case. Sewerage design, that is an absolutely different design. I'll discuss this in the next course also, which will be floated after this one is completed. So this is this. So D, and this D is a calculated D, from where you will have to see that the nearest that available diameter in the market. Suppose you have got, you see that you have got 10 centimeter diameter available, right? 10, say 20, like that. You have got a figure, say 12.5, say this is. Then in that case you have to, you have to select the higher one which is available, right? So the nearest higher, this one which will be available in the market also. Accordingly it has to be. Many a time it is very closely, suppose 10 is available and you are getting 10.5, then just to make it economical, the design is to make the design economical also, it is the lower one is selected. But in that case you have to check for with the lower this one, that again go back to that, and that whether this the area or velocity also is meeting the design criterion also, that you have to check, right, in a proper way also. So this is how that intake conduit is. Conduit means this carrying this system also, water carrying system. It may be raw water conduit, it may be finished water conduit also. Conduit may be closed, conduit may be open channel type of, so this is maybe this half circular, or circular channel open to atmosphere also. So different systems are there. Now in our next discussion we will take up this intake gate also. Next comes the intake gate. That is why I am not erasing this one. We will erase after discussing these details. Okay, so that this particular drawings could be referred repeatedly when we will design the intake, this gate, then intake the screens and strainers also. So I have told that there are different components also already discussed, so I am not going to discuss it once again. So today, up till today, we have completed that up to intake conduit also, and next time we will discuss this from the next, this one intake gate. So thank you so much for your patient and inquisitive listening to this particular this lecture video. Then I will welcome next time for the next this chapter or topic also. Thank you so much. Have a nice time.